Welcome to this module on database management, where we will focus on working effectively with MySQL. Our goal is to master relational databases and implement secure data handling practices for your applications. Let us begin by understanding the fundamental concepts of relational databases and their structure. We will explore how data is organized efficiently using tables, rows, and columns in these systems. A relational database is a structured system that organizes information into interconnected tables. It primarily organizes your data into logical tables which form the basic building blocks. These tables are then linked together using primary and foreign keys, establishing vital relationships. This structure ensures strong data consistency and maintains the overall integrity of your information. Now, let us consider what we mean by structured data within this context. Structured data stores information in a very well-defined, organized, and predictable format. Each table contains rows, which represent individual records, and columns representing specific fields. This organized format greatly facilitates efficient and quick retrieval of your stored data. Next, we have the crucial concept of ACID compliance for reliable transactions. ACID stands for atomicity, consistency, isolation, and durability, ensuring transactional reliability. It guarantees that all database transactions are processed reliably and consistently every time. Furthermore, ACID compliance maintains data integrity even in the event of system failures. Finally, relational databases universally support SQL, which is the standard query language. They use structured query language or SQL for all data interactions and management. SQL is the industry standard for both data manipulation and defining database structures. It allows you to manage and query your database very effectively and powerfully. Today, we will explore the various SQL language categories which are essential for database interaction. These commands are used for defining, manipulating, and controlling data within your database systems. First, DDL or Data Definition Language is used to define the database structure. DDL commands specifically define the database structure and its overall schema. Next, we have DML or Data Manipulation Language for managing data content. DML commands are primarily used to manipulate the data contained within your tables. Lastly, DCL or Data Control Language handles access and permissions. DCL commands control database access and manage all user permissions and security. Let us explore the core SQL commands essential for effective data management within a relational database system. These fundamental operations allow you to interact with your data, performing various tasks to maintain your database. First, we have the create table command, which is used to define the structure of new database tables. You will use it to lay out the blueprint for your data, specifying how information will be organized. This command allows you to precisely define each column's name and its specific data type, like text or numbers. Next, the insert data command is crucial for populating your tables with actual information. This command enables you to add new rows of records into your database tables, building up your dataset. You will use it to populate each column with specific values, ensuring your data is ready for use. Then, the select data command is your primary tool for retrieving information stored in your tables. It allows you to query your database and retrieve specific pieces of information that you need. You can use the where clause with select to filter rows, retrieving only the data that meets your conditions. Moving on, the update data command is used when you need to change existing records in your database. This command allows you to modify existing table records, ensuring your data stays current and accurate. You can change specific values based on conditions, targeting precisely which records need modification. Finally, the delete data command is used to remove records from your database when they are no longer needed. This command allows you to remove unwanted rows from a table, helping you maintain a clean database. You can delete specific records based on criteria, ensuring you only remove the intended data. Today, we will discuss the concept of keys in relational databases, which are fundamental for data organization. Keys are vital for establishing unique identification and creating clear links between different tables in your database. Let's start with the primary key. a very important concept in database design. A primary key serves to uniquely identify each individual record within a specific table, preventing ambiguity. This unique identification ensures that there are no duplicate rows, maintaining the integrity and uniqueness of your data. Remember, a table is designed to have only one primary key, making it the singular identifier for records. Now, let us consider the foreign key, which plays a critical role in connecting different tables. A foreign key is essentially used to link tables together, establishing connections across your database. It achieves this by referencing a primary key in another table, creating a bridge between them. Ultimately, foreign keys are essential for establishing meaningful relationships between different sets of data in your database. Today, we will explore key concepts in schema design, vital for database structure. These concepts are essential for building robust, efficient, and well-organized database structures. Normalization is a crucial process in database design that helps optimize data. Its primary goal is to minimize data redundancy, making your database more efficient. Conversely, denormalization is a technique used to improve data retrieval performance. It specifically aims to improve read performance by reducing the need for joins. Relationships are fundamental for linking tables and ensuring data consistency across your database. They effectively link tables together, ensuring consistent data integrity throughout your system. We will now review the systematic steps to design an efficient database schema. This approach provides a systematic way to organize your structured data effectively. The first step is to identify entities which represent the main objects. This means you determine your main objects, which will then become your tables. Next, you need to define keys, which are critical for table relationships. This involves assigning appropriate primary and foreign keys to your tables. Then, you apply normalization to optimize your database structure for efficiency. You minimize redundancy by using first normal form, second normal form, and third normal form. Consider indexing for queries to significantly speed up your data retrieval. Proper indexing helps to speed up your data retrieval processes considerably. Finally, you must handle many-to-many relationships carefully in your design. Use a junction table to effectively link entities in many-to-many scenarios. Today, we will learn how to connect PHP to MySQL databases using PDO. This method establishes a secure, flexible, and robust database connection for your applications. First, you need to establish a PDO connection to your MySQL database. This code block shows how to initiate a PDO connection and handle any potential errors. Next, we will insert data into the database using a PDO prepared statement. Here, we prepare an SQL insert query and then execute it with specific data. Today, we will focus on preventing SQL injection using prepared statements. This is crucial for safeguarding your database from potentially malicious attacks. This section shows a vulnerable SQL query, which is a common security risk. This code directly concatenates user input, making it highly susceptible to SQL injection attacks. This code block illustrates an insecure way of constructing an SQL query. Here, we demonstrate a secure query using a PDO prepared statement for safety. Prepared statements separate SQL logic from user data, preventing malicious code execution effectively. This code block illustrates how to use a PDO prepared statement for secure query execution. Today, we will discuss database security, focusing on user access and password hashing. These practices are vital for implementing robust access control and protecting your sensitive data. First, let us look at granting and revoking privileges for database users. Database administrators can grant or revoke specific permissions to control user actions and access. This code block demonstrates how to grant, revoke, and show user privileges in MySQL. Next, we will cover the essential practice of hashing passwords using PHP. Passwords should never be stored in plain text. Bcrypt transforms them into irreversible strings. This PHP code shows how to hash a password and then verify it securely. Well, we have covered a lot in this module, so let us review the key takeaways. These are the essential points you should remember from our discussion today. Relational databases organize data into structured tables, effectively connected by keys. SQL is the universal standard language for efficiently managing and querying relational databases. An efficient schema design minimizes data redundancy and optimizes query performance significantly. PDO offers flexible, secure P to MySQL connectivity, supporting prepared statements. Always use prepared statements and validate inputs to prevent SQL injection attacks. Implement role-based access control and hash passwords for robust database security. Lastly, remember that regular backups and monitoring are crucial for data integrity.